In this video, I'm going to cover the rest of the lesson on exponential functions, page 10 and page 11 in our booklets. So in this scenario, you've had a bad cough and you have to attend your little sister's choir concert. Okay, that's meaningless information. You take cough drops that contain 100 milligrams of menthol in each drop. That's your initial value or your starting value A. Every minute, the amount of menthol in your body is cut in half. This is going to be important. Write a function that models the amount of menthol in your body over time. Use X for minutes, so X is minutes, and Y is the amount of menthol, not method, but menthol. Okay, so here's what this is going to look like. Y equals the initial value, 100. The base I got to figure out, raised to the X power. If it's cut in half, that means there's 50% left. So if it's cut in half, my base is going to be 50% divided by 100 is 0.5. Half is gone, half is left. So how much menthol is in your body? You're looking for the amount of menthol. That's Y after 3 minutes. X is 3. So Y equals 100 times 0.5 to the third. You're just going to plug that in your calculator. And this is 12.5 milligrams. The next part says it's safe to take a new cough drop after the level of menthol in your body is less than 5 milligrams. How long will it be before you can take another cough drop? So what we're going to do on our calculator, we're going to go to home, we're going to go to graph, and you have this graph. We haven't used this before. Then I'm going to hit menu 3, menu graph, function, hit enter, and then I'll be able to type this in. So my initial value was 100 times 0.5, arrow out of there with the little caret button now, X. And that's going to graph the function. We can see part of it. So what I'm going to do now is if I go back to the menu, choice 7, I see table, and I'm going to do a split screen. And now I can see after 1 minute, there's 50 milligrams, 2 minutes, 25, 3 minutes, 12.5, and I can keep arrowing down. So essentially what I want to do, my work is going to be this table. So I have X and Y. 1 minute, there's 100. 2 minutes, there's 50. 3 minutes, there's 25. 4, there's 12.5. 5 minutes, there's 6.25. 6 minutes, somehow I messed this up. Hold on. 100. Oh, after 1 minute, I'm off. After 1 minute, there's 50. 2 minutes, there's 25. 3, there's 12.5. 4, there's 6.25. And after 5 minutes, there's 3. What did I do? .125 after 5 minutes. Oh, you can't even see that anyway. That's great. So 1 minute, there's 50 left. 2 minutes, 25. 3 minutes, 12.5. 4, 6.25. 5, 3.125. So it's safe if the amount is less than 5 milligrams. So after 5 minutes, you could take another cough drop because it's dropped down below that 5-minute mark. All right. Question 3 gets into some interpretations here. The most recent virus that's making people ill is a fast multiplying one. Its growth is modeled by the function. This is exponential because X is in the exponent. X is the number of days. So X is days. And V of X. So I read this V of X. This does not mean multiplication. Is the number of bugs. So the y-intercept, that's your initial value. That's when X is 0, Y is 2. So Y is the number of bugs. To start, there are 2 bugs. There are 2 bugs to start. Find the amount of bugs. So you're finding V of X present on the 5th day. x is 5. So this looks like y equals 2 times 1.87 to the fifth. 2 times 1.87 to the fifth gives you 45.7 rounded to the nearest whole number. We're going to say there's 46 bugs present. Then the last thing that we're going to cover here is domain, which is input values, and range, which are output values. So domain is x values or inputs, range is y values or outputs. So basically what we're doing is figuring out after 0, 1, 2, and 3 days how many bugs are present. So this y is really v of x. So I'm just going to go to the calculator and I'm going to use this again. And I'm going to go to graph, menu, 1, 4, we'll delete everything. And I can go back to menu 3. And I'm going to graph this function 2 times 1.87 raised to the x. And there's a little bit of a graph. I'm not sure why the table's not showing up. Let me see. All right, so menu, table, split screen. There we go. So on the initial day, there's 2 bugs. After day 1, there's 3.74, then 6.99, then 13.08. So the range is this. That's the range, those 4 numbers. The last part of the lesson, I really don't want to do part A. I'm not going to do that in class. The depreciation means decrease, exponential decay of Ian's new Mercedes is modeled by this function. You know that this is decay because the base is less than 1. X is the number of years since he bought the car. Determine what the value of 0.8 means. So I'm going to take this and I'm going to convert it to a percent by multiplying it by 100, 80%. We always go back to 100%. So if we started with 100% and now it's 80%, this is a 20% decrease. So if we're talking about the price of the car, it's a 20% decrease in the price per year. You think about iPhones, you think about cars, you buy them at a certain value and every year they lose value. And then you try and go and resell your phone that you bought for $1,000 and they're like, oh, we'll give you $5 for it. It's kind of frustrating, but that's the world we live in. So I hope this was helpful and I hope you enjoyed your time at EMCC. I'll see you next class.